All right, now we're going to do the parallel line, the line parallel to L through T. And one way to do that, there's more than one way, but one way, and the way I like, is using the rhombus idea. So effectively what I'm going to do is just pick a random point here on line L, and I'm going to use my compass, and I'm going to measure the distance between them. If we don't actually measure, I'm just going to open up my compass to that radius. And I'm going to go ahead and make that nice little arc. So then I'm going to keep my compass at that same radius. This is crucial. Keep the compass at the same radius. I'm going to go over to this intersection point and make an arc. And then I'm going to go over to point T and make another arc. And then we've got a naming point. Remember, 2 points determine a line. So point T that was given to me plus the new intersection point over there. Again, having a little trouble with my straight edge. It's a little easier to do that in the real world than virtually, but pretty good. And there's your parallel line. And that's it. Just to kind of understand why that works, if you want to keep listening, if you want to know why that works and understand it, that can kind of help you to remember. So this arc here tells us that that segment and that segment must be the same length because their radii are the same arc. So those two are equal. And then since I kept my compass at the same radius, I know that from T to here, because I used that radius, that's the same radius, I know from T to here, that segment is the same. So that's congruent to the other two. And then I also know, because I put my compass center here and went to there to make that arc, that that segment is also congruent. So all the segments are congruent, which makes that a rhombus, which is a parallelogram, which means that the line that I drew is in fact parallel. And that's why that construction works.